Are you ready to level up your future? Every Saturday, PDtv brings you maths class on PDtv YouTube channel, the place where knowledge meets opportunity.
High schoolers, level up your brain. PDtv maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. PDtv maths every Saturday.
Hello, welcome guys to another PDtv live mathematics session. All right. And I just want to welcome you guys back for the persons who were here previously, and also to people who are just joining today. All right, so we're going to take like the first minute or two to get some more persons on. So in the meantime, for the people on the YouTube space, just please introduce yourself, what's your name, and where you're joining from. Persons right in the YouTube stream chat. And let me know if my audio is on point, please. So let me know if my audio and my visual is working well. All right, so. All right, St. Catherine, Bronx. All right, we have people joining from all around the world. Good afternoon. Audio is excellent. Thank you for that feedback. St. Anne. Hey guys, and if you hear the roosters in the background, I might start to have to give them away to you guys. All right, North Carolina, welcome. Yeah, man. So start with the name, the place that you're from, and also the emojis, please. So my audio is good. How is my visual on screen? Please let me know. All right. Perfect. So for persons who are just joining today, I just want to welcome you to the session. I'd send the link. All right, we're gonna get you the link for the class. I just want to welcome you guys on the show. Well, the session actually. So you can learn what you actually missed out on in your previous math journey. All right. Excellent. I'm asked. Well, I copied and sent the link to the chat, but mine is not clickable, so I'm gonna ask them to send it from the studio. All right, so let us begin. So we are going to be wrapping up the laws of indices today. Right, so we're wrapping up the laws of indices. So we looked at 3 laws the first time that we started, and we touched on a 4th one. All right, so we're gonna go through these pretty promptly, but clearly so that you guys can understand what is happening. I'm trying to view it here. All right, so we started out by looking on the first three laws of indices, and I'm not going to go over these in details because remember, these three were at the recap level in the last class, which meant it would have covered it like 2 Saturdays ago. So the most I'll do for this is to tell us that we started out with the product law, the quotient law, and then the power to power law. So those were the first three that we covered. All right. And if you notice in the product law, the M and the N are the powers, and the A is the base. So we keep the base the same and add the powers at the top. All right. So remember, we recapped these last week, which meant we would have covered them 2 weeks ago. So we're going to move forward into what we're touching on today. All right. So learning objectives for today. So by the end of this lesson, students should be able to state and apply the zero index law. And we would have went into extensive explanation about the zero index law on Saturday. 2, simplify expressions with negative powers. 3, convert fractional indices to roots. And 4, simplify algebraic expressions involving advanced index laws. All right, so we're gonna be touching on quite a number of things today. Guys, and please remember, we had explored the zero index law extensively last week. All right, so with that said, I'm going to go straight into the solving of these problems that I have here. It's just general, guys. Anything that is raised to the power of 0 is equal to 1. And here we have the formula right here. A to the 0 power equal 1. A can be any number or term. All right. So that's where that is. So let's say for number 1, this is just equal to 1. Simple as we said it. Number 2, 12 to the 0 power. That's just 1. This is probably the simplest rule of all the rules. Number 3, x to the 0 power. That's just 1. Patricia Dean. Hold on. Give me a sec, guys. A person who are asking for the link. Right, so all this is saying, whatever is raised to the power of 0 is just 1. It doesn't matter how big the quantity is. All right, so that's basic. All right, so let's move forward now. What do you think? How do you approach number 4? We know that the answer is going to be 1. But how would you approach number 4 if you were solving number 4? All right, this looks a bit similar to one of the rules that we covered last week or 2 weeks ago. All right, guys, the link to join the Google Meet class was sent in the YouTube stream chat. Right? It was also pinned, so please use that to access the class. And guys, if you're going to access the Google Meet class, right? It is an environment for you to have more direct contact and communication. Don't join the class and then you guys just sitting, not even responding to a simple question. All right, so use it as an opportunity to reach me more directly. All right, so number 4 looks like something that we covered already, which was the power to a power rule. Right, so any quantity that is raised to the power of 0 or raised to a power, we simply just multiply powers that are in the parentheses by the power that is on the outside. So the 3 has a power of 1 and the y has a power of 1. All right, so we simply just multiply this 1 by 0 and that 1 by 0, and that's going to be equal to 3, the 0 on the outside, which is the power, times 1 on the inside, that's a 0, and y to the 0, which is equal to 1 times 1, which is equal to 1. All right, guys, so sometimes a basic problem can be extended to reflect some of the previous laws. What would be your first approach? So if I tell us that number 5 values 3 marks, what would be your first step? What law that we covered previously can we use to solve number 5? Guys, the link was sent in the stream chat. Please use it as best as possible. Right, guys, so stream chat people, what could we do for number 5, considering the previous laws that we covered? Let me see persons who want to enter. The thing is, I didn't get any notification for the entry. Let me see. All right, guys. I just accepted 4 just now. All right, so you guys were accepted in. Sorry about that. So let's go back to our page. All right, so based on a law that we covered before, how do you approach number 5?
Sir.
Hello. How would you approach number 5? All right. I saw somebody said, and guys, people on the Google Meet, if you're not responding to a question, please turn off your mics or mute the mics. All right, so somebody says base remains the same. Okay. But the powers of 3 is equal to 3 minus 3. All right, perfect. So this person is saying 7 cube divided by 7 cube they are saying we could just do this 7, 3 minus 3 based on the quotient law that we covered previously. And the quotient law is this one right here at number 2. Let me expand the screen a little bit. All right, so that's the quotient law. So we apply the quotient law to number 5. So that gives us 7 to the 0, which is equal to 1. Some of the questions will be organized in such a way that you have to apply the previous laws to get to your answer. All right, then this number 6 will give, so we have the 0 on the outside.
2.
What's that? And we don't even have
You
to
would
complicate
take
number 6.
away.
All right, I'm gonna get to you. We don't even have to complicate number 6.
You would take away.
Repeat that.
You take it away.
We're
You would
looking
take
at
away.
number 6.
Yeah.
What are we gonna take away?
The 2 and the 0. I guess
No, we don't take the 2 and the 0.
the 4.
All right, look at this. Hold on. Look at this law that we covered last week. It simply says, whenever there is a power on the outside, in this case the n, we multiply it by the power on the inside. So that's one route we could have taken. But remember, this formula that is in colored on screen, whatever quantity is raised to the power of 0, and in this case, everything in the bracket right here is raised to the power of 0. So it's just a 1. So it doesn't matter how complex the problem looks, once it is raised to 1, once it is raised to 0, we simply just equate it to 1. All right, so let me check if anybody else wants to be let into the class.
What's that X thing?
All right, give me a second. I'm going to check on it in a minute.
What's that X? That's a multiply things at number 3.
Give me a second, please. 1 second.
Okay, when I come back at that.
My screen is kind of freezing up a little bit. So the persons who are waiting to join, kind of experiencing a little bit of freezing. As a person who asked us about number 3, what's the question for number 3?
I was just saying, what the X, that's a X there, what the 0 beside it?
Right, so the 0 is at the top right-hand corner.
Okay.
So the 0 is a power.
Okay.
And any number that is raised to the 0 power, the answer is always 1. For example,
No.
Um,
What, sir, come off?
he's gonna join back.
Okay.
Did he leave? Where did he go?
He soon come back.
What you, the girl was trying like a spotlight beside her. What did she say?
He said, "Where did Sir go?"
Oh, I didn't know where sir goes, so I just asked where sir goes.
Wait, let me check on YouTube real quick.
Okay.
I said YouTube.
You saw him?
Yeah, but he's not. He's not talking. He's not even in the. I think he's in a different Google Meet.
Okay, so he does not show the work on it, so we can go revive over and go like add it up and stuff.
Yeah.
So why the workout picture do not show on the screen so we can talk about it? So when he
Yes,
comes,
sir.
I'm coming back up, guys. Don't worry.
oh, he's back.
Get your screen on YouTube is gone.
Yeah, but
Yeah,
just hold on. They'll come up back right now. No worry yourself.
okay.
I'm coming up back on screen in a minute.
Okay. It looks like he's gone again.
Sir, somebody said in the YouTube chat that they cannot join.
Oh,
Yeah, give me a second.
it was very difficult for the first time, so I just sent in the chat like, you can send the link, please, and I send that in the chat, and then I get the link through. And he gone again.
I'm gone again.
I don't know why he gone again.
Well,
I just want to know that
He did say that there was something wrong.
right there.
He said that there was something wrong.
Oh. Yeah, because the truth is, the screen does not show up on. So you have to move. You have to move up on and on just to find back the screen to teach us about mathematics.
I mean, I get it now because I wasn't here in the other classes because I had netball practice, but I get it.
Do the other week. Do the other week. Yeah, the last time I didn't get to go on it because of the it was showing the wrong dates. I didn't get to go on it.
Wow.
Sir, come on, but he joined the lane, but he does not show. He muted his mic. Something probably works. Something probably wrong. Like it probably chip out, or probably yeah. But it's taking a long time. Right now it's 1:25, I guess. Yes, it can. Um, Alana, I just wanna say like thank you or oh oh Sarah put it on back, so we're gonna go back to study, I guess.
Yeah,
But
but
mute is back, so we're not gonna talk to each other. Like, okay, so I put it on back so we can so we can study together, I guess.
see, it's onto the screen now.
Yes, so I guess law for zero index law and non-zero number raised to the. Someone is moving the laptop or something. I don't know if it's a laptop or something, so I used to do this right now because. Okay, so it's a raised to the power of zero equals 1. So I guess sir needs a little help on it because his mic is mute. So I guess you need a little help on that because you need to turn on his mic to talk to us because he's right now moving out like the laptop thing that you slap around. You just use that to like fix it up. Sir probably go to get the person that wanna link with us. He probably going to link them. One to the rest of the classmates in the class, right? I don't know if it's more than two classmates in here because two of the classmates right here, they mute their mic and I know they couldn't even talk to us. Let's go. Let's go. Hello. Yes, see that I'm outside. Okay, so I'm just gonna talk to the peoples in the chat. Like, if you want to like go in the chat and like say something, you guys can just say.
And that's what I'm doing.
What he said? I'm gonna like go come off the screen and tell the person in the chat on YouTube tell them that tell them in mathematics unlock the secret. I'm gonna tell them like the link is right in the chat, bro. Why you can't even look in the chat and say, oh yeah, press on the link and just you get on the link easily. But they don't want to do that. They just want to keep on asking you, annoying you.
The chat. I'm trying to tell the Sir soon be back.
Oh, yeah, they do not want to listen to you. I don't know why they don't want to listen because right now the link is right in front of them. Why they just don't want to press on the link? Jeez, I don't understand why these people don't learn to understand that people need to go on
That way they can hear us. The Google Meet is still on. So, guys, you have to wait. Sir soon be back.
Okay.
Looks like he's going through his files from last week's lesson. Yeah.
Oh. These people really want to learn. I'm just gonna try to tell them, sir.
The host said that Mr. Lincoln lost connection.
What? Let me go back on the Google chat. I'm just coming back. Wait, someone said something. Someone said, what's your problem? These people need to learn.
Julie, it looks like they don't see what we're seeing on the screen.
Yeah, because literally I just said to them in the chat. That said, guys, the link is right in front of you. Why you don't want to? The sir's not there yet. Sir's not there. And they, well, like a lady or a man sent something in the chat. Like she said, "What's your problem?" I don't understand these people. They need to focus next time.
High schoolers,
When
level
they
up your
want to
brain.
help, they want people to help them, but
Sessions
they do
every
not have any
Saturday.
manners inside of them.
Algebra,
Like,
fractions, equations,
the
functions,
given that
all made
people
simple,
give them because
all
I'm
made
right here
fun.
doing something in this class right now, and those people said nothing to help them go on the link.
So you all jump on the bus. Let's go to where your future is bright.
Right now,
So what we
people
say,
continue giving
so
us
what we
attitude and disrespectful, and they don't understand
no game,
that
no
they want to
gimmicks,
go on the link and
just
they do not want
knowledge
to
we
say
are
things, this and that. Yeah, but they just want to
What
come
not
up
draw
to people and give people this manner and
but have we love? PDtv
I don't
Max
understand why people
every Saturday. PDtv Max, come learn me right way.
The book of Jesus, because they do not know nothing about
High
Jesus.
schoolers,
They
level
need
up
to
your
focus.
brain.
They need to work hard.
PDtv Max sessions every Saturday. Algebra, fractions,
Google chat.
equations,
What you said?
functions, all made simple,
After Google chat,
all made fun.
Yeah, but he's not
you
talking
are
because he's not talking because his mic is mute, and Baxter don't want to show us the screen.
So you all jump on the bus. Let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV, matter we love. PDtv Max every Saturday. PDtv Max, come learn the right way.
Are you ready to level up your future?
High schoolers, level up your brain. PDtv Maths. Sessions every Saturday. Algebra, fractions, equations, functions. All made simple. All made fun. So you all jump on the bus. Let's go to where your future is bright. Matter what we say, matter what we need.
Microphone.
No
sorry.
game, no.
Sorry for the interruption.
Sir.
Yeah.
Uh,
Is my audio? No, how it's going?
Okay, so now I could see your screen.
Yeah, man, because I said it was just some technical difficulty. And guess what? So you see, for the rest of this session, I'm gonna ask you guys to just mute the mics. We don't need all of that.
Sir, the persons in the chat did
Yeah,
say
but right. So I spoke to them already. I understand. I spoke to them already, so that fixed. So let me know if we're good now, right? My audio is good.
yes, sir. Yes, sir.
Yes,
You're good.
sir.
How
Yes,
is
sir.
my visual?
It's fine, sir. I could see everything.
All right,
Yeah.
perfect.
Good.
Those are some of the unforeseen circumstances whenever we are working with
People in
technology.
the people in the chat and the user watching the video, they said they want a link with us, but some of the people in the chat are
Hold on. I sorted out that already. So we're gonna bring things back now to the lesson. All right. And for the persons who are joining the Google Meet class from the stream chat, please, if you don't have a question or any constructive comments, please keep the mic muted. All right. So let me.
Sir, they said that they wanted to see the working now.
Yeah, but listen up. Guys, give me a moment, please. You're here week after week, and you see how we do the lessons already. So just give me a chance to progress through things so you guys can get it. It's not the first class you guys coming. So you know how we do it already. All right, so we would have covered 1 to 5 already, right? Because we know that all these answers are equal to 1. All right, we did all of these already. We got the 7, 3 minus 3 equals 7 to the 0 equal 1. We did all of these already before the interruption. Let me know if you guys hear my audio, please.
Yes, sir.
Perfect. And for number 6, everything that is in here, 4a squared b raised to the power of 0, that is equal to 1. So even if it looks a bit complex like this, the answer is just 1. Any question about the 0 index law before I move on? Any question, anything that you want me to clear up? Please, now is the time. All right. So someone says, show the working for number 6. All right. Violet Ramsey. I'll do number 6. I mean, based
Sir,
on
I
the
can't
rule,
see the screen.
based on the rule, That's basically the working out for number 6, based on the rule that we're looking at, because it says that any quantity raised to the power of 0, the answer is 1. So everything here that is raised to the power of 0, the answer is 1. But I'm going to bring that to a different page and expound. So it was 4x squared b. All right, so we're going to work out number 6 using a different method. So open bracket 4x, what was it, x? That's a. So 4a square b, all raised to the power of 0. Because the parentheses or the bracket keeps everything inside together. So it treats it as just one term. So method 1, let's call this method 1. Method 1 is just what the rule says, equal 1. However, let's say we have method 2, where we have the same problem, 4a squared b raised to the 0 power. All right, there is a rule that we covered last week that says, for example, if we have x let's say 2 and 3, and those are inside the parentheses, and there's a number on the outside, we are going to multiply each power by the number on the outside. So this would give us x 2 times 4, then y 3 times 4, because this 2 and this 3 came from on the inside, and this 4 was on the outside. So this is going to be equal to x 2 times 4, that's 8, so that's to the 8th power, and then y 3 times 4, 12. So let's go down to this problem now, where we have the same situation. This power was 2. And as I said in previous lessons, any number that is by itself has a power of 1. So the 4 has a power of 1, and the b has a power of 1. Let me know if you guys are catching on. All right, let me see who else is waiting to enter the class. All right. All right, you guys probably have to re-enter again. I don't see anybody waiting to be added. All right, so let's try this. Testing. I'm good? All right.
Yes, sir.
All right, perfect. I had to switch over the mic. Excellent. So back to this part now, guys. So we could have avoided all of this if we just stick to the rule that we got. But just in case you're asked to expand. So now guys, this 0 is now on the outside. The power of 1, which is on the 4, the power of 2, which is on A, and the power of 1, that is on B, equal. So now we're going to have to multiply each power on the inside by the 0 outside. All right. So I hope you guys are picking this up. So we are applying the power to power rule to help us solve this problem. All right. So now this gives us, let me change my ink. So 4, 0 times 1. So we're now multiplying the powers. So 0 times 1, 0. Then A,
0.
0 times 2, that's what?
0.
Yes, 0. And then B goes here. 1 times 0 is what? 0. But remember, anything raised to the power of 0 is 1. So all this is, so 4 to the 0 changes to 1. A to the 0 changes to 1. And B to the 0 changes to 1. Then 1 times 1 times 1 gives us a 1. Any question, comments? Valerie, let me know if you saw how we got that. Let me check on Google Meet again. All right. My note. It's the same link we're using for the Google Meet, so I'm not sure why it's not allowing you guys to join. So refresh your device or something and try again, because I had to refresh my screen for me to get back in a few minutes ago. All right, so any question about the zero index law? Any question? Now is the time to mention it so I can clear it up before we move on. Google Meet people. Any question?
No, sir.
You sure?
Yes, sir.
All right. So let me go back to boom. So now this rule is the fifth rule or law of indices. And just to do a little bit of recap, guys, the first three rules that we covered are listed here. So the first one was the product law or product rule. The second was the quotient law. The third was the power of a power. And we recently moved into the zero index law. All right, guys. Persons were asking to be added to the Google Meet space. I am not seeing anybody in the waiting room, so probably you might want to just refresh your screen a bit, then head right back in. All right, give me a sec. Let me. All right, so I think those persons were just added. I had to make a slight adjustment on my end. All right, guys, moving on now. We had a slight delay, but we're still moving forward. So we're now going to move to the fifth law of indices. Persons who are asking to be added. I just added some people just now. So please have a look. All right. Can someone read what number 5 is saying? So somebody in the Google Meet space, read to me what number 5 law is all about. So Google Meet person, please read me this definition. Somebody from Google Meet.
Law 5, negative index law. A
One
negative
person.
exponent means take the reciprocal of the base and make the exponent positive.
All right. Thank you very much. So this word is reciprocal. All right? Reciprocal. So reciprocal just means to flip, right? So flip, that's basically the concept of reciprocal. All right, guys, mute your mics again, please. So Google Meet people, please mute your mics if you're not responding. YouTube stream space, please let me know. Let me see some emojis, some stuff so that I can know that you guys are okay over there. What was that? All right. So reciprocal means flip. So it says a negative exponent means take the reciprocal of the base. So the base in this case is 2. So this is the base. 2 is the base. Take the reciprocal of the base. So the reciprocal of 2 is 1 over 2. Let me use a different color.
Also, I was asking at number 12.
We're not looking at number 12 as yet. We're at number 7.
I'm just asking, like the X thing that's at the front minus the 3. What is that thing? The X thing means the CC.
All right, that's a good question. However, we're gonna progress up onto number 12. So by the time you reach number 9, you're gonna get what that means. All right, YouTube stream people, let me know how you are over there. So by the time I reach number 9, you're gonna understand, okay? All right, let's go.
Yes.
All right, YouTube space. I'm not getting much feedback. Is my audio okay?
Yes, sir.
In the
Very
YouTube setting.
okay.
Persons
Yes.
who have viewed me on YouTube. How's my audio on YouTube? All right, sir. Perfect. All right, let's get down to business now. So,
Have the chat.
what's that? All right, so take a look at this illustration. All right. All right. So let's say, for example, we have the letter, I'm just going to use a letter in this case, the letter M by itself. M by itself is being divided by 1, which in this case, M divided by 1 gives us M. So M divided by 1 is just a different way of writing M. All right, another example again. If I have the number 4,
I did think it was algebra you were doing.
give me a second, please. So if I have the number 4, 4 is the same thing as 4 divided by 1. Mute the mics, which is equal to 4. So, moving on to the solution now. 1 over 4 in terms of its reciprocal, or let's go back to the M over 1. So M over 1 reciprocal is 1 over M. So in terms of the definition, the reciprocal is a flip of a term. So M over 1 is equal to 1 over, is the same thing as 1 over M in terms of the reciprocal. And 4 over 1, what would be the reciprocal of 4 over 1? Somebody answer that. What's the reciprocal of 4 over 1?
1 over 4.
Excellent. 1 over 4 equal to, perfect.
1 over 4.
Thank you. 1 over 4. All right, now, so we're going to go back to the problem now. So if the definition said that we take the reciprocal of the base, what's the base in this case for number 7? What's the base for number 7? What is the base for number 7?
2 minus 3.
So, all right. So look, this number here, so this is the base. These are the bases right here. Don't forget that.
I thought it was 2 minus 3.
2 is the base, and negative 3 is the power, or the index. So now, what is the reciprocal of 2? We just did some examples just now. What's the reciprocal of 2? Or based on the formula at the top. So we had a to the negative n equal 1 over a to the n. So what will number 7 be equal to using the formula at the top? What's number 7? The answer is right there looking at us. So using
3 over 2.
look at this formula here. Look at this right here. Based on how those are arranged.
Is that an example?
I mean, it's the general formula. It's an example actually. Based on how that is arranged. All right, I'm gonna do number 7 for you guys. So equal. So we're gonna find the reciprocal of the base. The base is 2, so the reciprocal would be 1 over 2.
Yeah.
1 over 2. And then it says make the exponent positive. Make the exponent positive. So the exponent is negative 3. So we change the negative 3 to a positive 3 and put it right here. Any question? All right, so YouTube, perfect. So I'm seeing 1 over 8 and all of that. So now 1 over 2 to the 3 would be equal to 1 over
You're muted.
2 times 2 times 2,
Yes, Grandma.
Why?
Because
which is
sir,
equal
so
to 1
until when you ask me a
over
question, you
8.
can unmute it.
All right, guys, so let's move on to number 8.
Oh my God.
All right, let's go. Number 8. Let's go, guys. We're looking at number 8.
1 over 5.
All right, one second. I'm gonna come up on that. 1 over 5. Anybody else?
1 over 5.
All right, perfect. All right, so the rule is always to look on this first right here. So we have 1 over 5. Let me use my blue. So equal to 1 over 5. What's the exponent on the 5?
Exponent on the 5 is
So we change the,
2.
I hear it, I hear somebody say it.
1.
What's the exponent on the 5?
1.
1, exactly. Because remember, the 1 right here was negative, right? And the definition says make the exponent positive. So we change from a negative 1 to a positive 1 and put it on the 5. So that's just 1 over 5 to the first gives us 5. All right, guys, work on number 9, everybody, please. Number 9, let's go. Google Meet, YouTube space. Work on number 9. Same procedure, nothing changes. Let's go, guys. Number 9. Google Meet.
It is. What's going on? It is time to go.
All right, I know you guys have the answer already, Let's go. So x to the negative 4 equals.
Oh,
All right. So number 9.
over x.
All right. So firstly, guys, what is the reciprocal of x? That's the first part.
4.
4.
What's the do not look on the negative 4 as it. What's the reciprocal of x? So always remember, guys, we're looking on this x at the front first. Then we move on afterwards. What's the reciprocal of the x? And guys, it's the same procedure. Even though it's a x, it's the same procedure that we did with the 2 and the 5.
1.
So reciprocal of x is what?
Is
We have 2 in this case. In number 7. The reciprocal of 2 was 1 over 2. The reciprocal of 5 was 1 over 5. So what's the reciprocal of x?
1.
What is the reciprocal of x?
4.
No, do not look on the 4.
1.
1 over what?
X.
1 over x. Guys, for the reciprocal, just take the first term or base and put a 1 in the numerator. Where does the 4 go?
Beside the X.
Thank you very much. Beside the x, so we put it
Start the
right there. Right. What about number 10? How do you approach number 10?
You take away -2.
All right. Look at it this way. Since there's a number at the front, all right, guess what? I'm going to do an example that's different from that one. I'm going to use 5. Let me put a line right here. So that example is going here. I'm going to use 5x to the -2. Looks very similar to number 10, but a change in digit. All right, so 5 is multiplying x to the -2. So this is multiplication. So think about it this way. Forget about the 5 for now. Just forget about the 5 for now. So we're going to be equal to just put the 5 as it is and apply the rule to x to the -2. So similarly to how we did the previous examples, especially number 4, what would be the reciprocal of x? I ask the same question again, you know. Same thing I asked previously for number 9. What's the reciprocal of x?
1.
What is the reciprocal of x? I literally asked you guys
Answer.
about the same question. All right, so Ramsey, reciprocal is 1 over x. 1 over x. And the negative exponent, which is -2, we change the 2 to a +2 and put it here. So equal, so 5 times 1 over x squared. If we multiply those two, the 5 goes at the top. X squared comes here. All right, any question? YouTube space, any question? Google Meet, any question? Any question from the persons on Google Meet?
No, sir.
Who was asking about number 12?
Newly, sir.
Who?
Newly.
All right, we're gonna. Okay, so I did the 5x -2 example. Now I want you guys to do the actual number 10 that speaks of 3x minus 2. That's one is for you. Number 10.
Yes, sir.
So work on that one right now. YouTube stream, let me see the emojis coming in rapidly. All right, YouTube, a long time I'm gonna ask you this. If you guys learning, let me see the word learning in the chat. Please, YouTube space. If you're learning, let me see it. Giving you guys a couple of seconds to finish up number 10. Perfect, perfect. Win some learning. Okay. So I just treat somebody I learn
I'm
after YouTube.
finished.
Okay, you finished number 10?
Yes,
All
sir.
right. Let's look at it now. Equal. What will this be equal to? Right, it's a person who said they finished. Tell me what you have.
I have 3 over x2.
3
Finish.
over x square. How you get that?
Because I used the method that you did for the example.
Okay, for the example. Okay. So if you're doing the x to the negative 2 part, we're gonna have what? X or 1 over x
1 over
equal 3 times 1 over x square, 3 over x square. All right. So that's what you did.
Yes, sir.
All right. Excellent. So now we're moving on to number 11. I want us to start number 11. I'm not going to tell you what the answer is as yet.
Oh,
So
sir,
work on
this is
number 11.
easy.
Yeah, man, that's all right. That sound bad. Work on number 11 so I can get it. Giving the guys like 1 minute for number 11. Anybody finish? Let me see YouTube. What's going on YouTube? All right, guys. We're looking at number 11. What's our answer for number 11? All right, number 11, guys. So what is the base for number 11? What's the base?
1 over a.
Remember, the base is everything in the bracket. So the base is 2a. So what's the reciprocal of 2a? What's the reciprocal of 2a?
2a
Same
over
procedure.
1
Look at
or
all the
1
previous.
over 2a.
1 over
1 over
2a.
2a? Perfect. All right. 1 over 2a. And remember, that's in parentheses. Where does the 3 go?
Outside the bracket.
Okay, so the 3, so the negative 3 changes to a positive 3. All right. Equal 1 over. All right, so you guys remember the rule that we did earlier?
Yes.
Where we had, there's a 1 at the top here, and there's a 1 beside the a. So we have to multiply the powers. So 2, then 1 times 3, that's 3. Then a goes here, 1 times 3, 3. So what's our final answer for this one?
One.
Guys, I know this might get a little bit
Wait, two, sir.
right.
You 2 times 3, and wait, no, 3 take away 3, that's 0. So you're gonna put the 0 there. Then that's gonna be 1/2 A0.
All right. So
Why you
remember,
got 1?
we only take away when the bases are the same. But these bases are 2 and A. Google Meet people who is not responding. Mute the mic. All right, so I mute it permanently. All right. So now 1 is over. Now 2 to the third power is 2 times 2 times 2, which is 8. And A to the third is just A to the third. So our answer is 1 over A cube. I'm going to pause this a second and allow you guys to get some questions in. I'm seeing, so Ramsey, so the 3 that was on the outside in the power, this 3, we multiply that 3 by the powers on the inside, which is the 1 and the 1. So 3 times 1 gave us the 3, and 3 times 1 here gave us the 3 again. So we now have 2 cube times A cube. So the 2 cube by itself is 2 times 2 times 2. Right, is raised to the power of 3. So we multiply 2 by itself 3 times. And that gave us 8. And then the A cube will come back over here. So that's how we got the 1 over 8A cube. And remember, guys, this is the laws of indices. It's important that you know the topic so you can link it to the actual problems. Laws of indices, and this is negative index law. Any question? YouTube space, any question? So I'm going to open 1 minute for questions, just in case you guys have any issues. I'm going to open the question in for 1 minute so you guys can ask for certain clarification. Any question? Google Meet, any question? YouTube
sir.
space? Okay.
No, sir.
All right. So the infamous number 12. So if we look at this problem, it has 2 sections, right? It has x to the negative 3. That's 1. And then it has a second section, which is y squared. That's two parts of the problem. And each part is multiplying the next part. So this is basically saying x to the negative 3 times y squared. Now guys, based on the same procedure that you carried out for the previous examples, what would be the result for x to the negative 3? You guys must know this from your head right now. We're looking at the green part. What is x to the negative 3 equal to? Come guys, we did type 5 example.
X, 1
Go
over
ahead.
x, and the negative 3 turns into a positive after.
Thank you very much. Excellent. 1 over x. Let me fix this. Let me clean that up a little bit. Sometimes guys, remember, after you give your answer, please mute the mic. All right, let's go back to this now. So you said 1 over who? 1 over
X. After you put the x, you're gonna change the negative 3 into a positive.
into a positive. So 1 over x cube. Perfect. Can we apply the rule to y squared? Can we apply the same rule to y squared?
Yes, sir.
Sir,
Are
are
you
you
sure?
turning down like the call speaker?
What's that?
They're turning down. Are you turning down the speaker? Call speaker.
You guys stay with me now?
No.
Yes, sir. Yes, sir.
No.
No, but why you answer if you cannot hear me? All right. So can we apply the same rule to y squared? Guys, come on now, focus. Can we apply the same rule to
Talk to you.
law number 5?
Your ear. She can hear you. I can hear you now.
All right. So since there is no negative in the index, we're going to keep the y squared just the same. So y squared. So this is just equal to
PDtv
y
show.
squared
Someone is in
over
there.
x cubed.
Oh.
So that's how we approach number 12. Okay, so Valet Ramsey says, I think y squared remains the same. And it does remain the same. And then 1 over x cubed is going to multiply by y squared. And we now change it to y squared over x cubed. All right, guys, so we're going up until 2:30 to kind of make up back for the time that was stolen from us due to the interruption of the devices. Let me see. Fractional index law. You know what? Before I even move to this one, let me all right. I'm going to clear up something for somebody. Someone says they don't understand why the y square goes at the top. All right. Let me bring over the question. So x negative 3. Let me clear that up now. So x negative 3 y square. All right. So we did this already. So we're focusing on the x to the negative 3. So that's going to be 1 over x cubed times y square. All right. When we're multiplying, for example, let's say we have 1 over 2 multiplied by 3. We can put a placeholder below the 3. And this clarification is for Ivan Barton. All right, so 1 over 2 multiplied by 3. So we can put a 1 below the 3. Once we cannot do any cancellation, we multiply straight across. So 1 times 3 gives us 3. 2 times 1 gives us 2. So the same procedure applies for the answer that we got at number 12. 1 over x cubed multiplied by y square. So we can put a 1 below the y square. Same procedure. If anything cannot be cancelled, we multiply straight across. So that is equal to 1 times y square equal y square over x cubed times 1 equal x cubed. All right, so Ivan, I hope that clears up your question. All right, so let's look on. Is Marsha? Okay, thank you, Marsha. All right, so on this screen, guys, I want you to give me 5 examples of some problems that involves negative exponent. So this is what we're looking on. So a to the minus m equal to 1 over a to the m. So these 5 questions will be your homework. So let's go, guys. So we need 5 problems similarly to what we just solved. So Google Meet and YouTube, we can work together and create 5 quick problems. We just have less than a minute to go. I'm gonna give you guys the first one. And the first one is b to the minus 3. So writing 5 problems for you guys' homework. Come on, Google Meet, give me 2 examples. Similarly to what we just covered. All right, so
Sir, what
2.
are we doing, sir?
We're creating 5 problems for your homework. 5 problems that are similar to what we just covered earlier. So I gave us 2 already.
Okay, sir.
Go again?
Sir, 9
9,
negative 3.
negative 3. Perfect. We're doing 2 more.
8.
8.
Yes. To the
Mhm.
negative 2.
Negative 2. I want a letter in number 5 now. Put a letter in number 5. Let's go for number 5.
Y.
All right, so y,
To the negative
negative
9.
9, 9. And I'm going to put a 4 at the front. All right, guys, so this on screen is for you to get some practice. I'm going to put homework. So please take a screenshot of this page and work on those for homework as a way of practicing what we have just covered. All right, guys, so we had the delay, but we made up back for the last time, and it came out well. So I just want to thank you guys for attending today, and please remember to share the link to the classes that we have covered already on YouTube to friends and families who wants to get some extra math help. So with that said, this is where we're going to end it for today. Remember, PDtv math session each and every Saturday at 1 to 2 p.m. on the PDtv channel. All right, guys, so have a wonderful weekend.
High schoolers, level up your brain. PDtv Maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV, matter we love.